Okay, today we are going to learn about some set operations which we use to combine sets and modify sets. Most important ones are the union, intersection, and complement. The union of A and B is the set of all elements such that X is an element of A or B. Key word here is or. Okay. Intersection means that it needs to be in A and also in B. So basically your union means it's got to be in one set or the other, and that or implies that it could be both. So it's in A or B or both. The intersection means that it's got to be in both A and also B. Another operation is the complement. There are several notations for this. You should be familiar with all of them, although I'll mostly use the apostrophe, this notation here in this class. So we can use complement with A, the little prime or apostrophe, A with a superscript C for complement, or A, and this one's a little bit difficult to read on here. It should say A with a little tilde or squiggle up there in the superscript. That's the way you want to make sure you write that one. Okay, and so what this means is basically the set of elements that are not in set A. And we have to be careful that we realize the only elements under consideration are those that are in our universe or our universal set. So this means everything in our universal set that is not an element of A. Little note here. A is a subset of A union B, and so is B, because everything in B also has to fall into the union. The union contains everything that's in A or B or both. So if it's in B, it's got to be in the union. Okay, the intersection of A and B is a subset of A. Good way to remember intersection is think of the intersection of two streets where two streets cross. Okay, so if you are on two streets that cross, let's say you're on 1960 and Aldine Westfield roads. If you are on both of those, that means you are in the intersection, that area which is covered by both streets. Okay, and that intersection, if it's in the intersection, it has to be in A and B both. Therefore, it is indeed an element of A. So the intersection is a subset of A. Similarly, the intersection is a subset of B. We call A and B disjoint sets if their intersection is empty, if they do not overlap at all. If you're thinking streets, think of two streets that do not cross. They run parallel and they never cross each other. The intersection of those would be empty because those never cross. There's nothing in the intersection. Here's an example. Let's just combine these sets in a few ways here. We're going to let the universe be the set of integers from 1 to 8. And H, K, J, and L we have specified here. Okay, so what is H intersect K? Okay, so this means the set of elements that are in both H and also in K. Well, 1 is in both of them, so 1 will be here in the intersection. What about 2? Is that in both of them? No, 2 is only in K, so we can't use 2. But what about 3? 3 is in both of them, so we can use 3. What about 5 and 7? They're in H, but they are not in K, so we can't use them. These are the only things that are in the intersection of H and K. Now, what if we did H union K? Notice that union, it looks like a U except without a tail on it. Okay, here's what I would normally do is just pick one of the sets, write everything down. So 1, 3, 5, 7, and now you want to put anything in from K that's not already here. Okay, so if we look at K, what's in it? 1, I already listed it. 2, ooh, I haven't listed it, so it needs to be here because 2 has to be in the union as long as it's in either H or K or both. So 2 needs to be listed. What about 3? It needs to be listed, but it's already there. I don't need to list it again. I only list them once. So that's H union K. What about K intersect J? Okay, this means it has to be in both K and J. The only thing I see that's in both of them is the 2. Okay. What about K complement? Okay, this means everything in the universal set that is not in K. So K has 1, 2, 3 in it. What things are missing? 4, 5, 6, 7, and 8. Those are in K complement. Let's do a more complicated one. Let's do J union L complement. Okay, so the first thing that we want to do is figure out what J union L is. Okay, so J union L will be everything that's either in J or L or both. And if you want to write them in order, you can. From L, I'll need 1 and 2. And then from J, I need 2, 4, 6, 8. But I already have 2, so I only need to list 4, 6, and 8. Okay, so once we have J union L, now we can find the complement. Okay, so that means everything that's in my universal set that was not in J union L. Okay, so you can go through your universal set. 1, 2, those are in there. Ooh, 3's not in J union L, so I need to list that. That's part of the complement. 4 is in there. 5 needs to be listed because 5's in my universal set but is not in J union L. And then I also need 7. Okay, that's an introduction to unions and intersections and complements. Venn diagrams help us to visualize set relationships and operations, and we'll be doing more of these. But here's an introduction, just using 2 sets. Let's look at C intersect D. And just for the sake of our example, so that it's a little easier to visualize what we're talking about here, let's let C be the set of cat owners in this class, and then let's let D be the set of dog owners in this class. Okay, and maybe that will help us to figure out what C intersect D and the others actually mean. So for a Venn diagram, we're going to draw a box that indicates our universal set. And then we're going to draw a circle for C and a circle for D, and we're going to assume that they overlap. Okay, so we want to shade the area that corresponds to C intersect D. Okay, this means it's got to be in C and also in D. Remember, the key word here is and. Okay, it's got to be in both of them. So where will that be? Well, this is the area that's in both, right? Okay, what does that mean? That's going to mean people who own a cat and also a dog. Okay, they are both a cat owner and a dog owner. Okay, let's assume we're still using cat owners and dog owners. And let's try to draw a Venn diagram and shade C union D. Okay, so C union D means you are a cat owner or a dog owner, and it also allows for the possibility of both. In other words, if I were to ask you, do you own a cat or a dog? If your answer is yes, you should be shaded. Okay, so what areas are going to be shaded? Well, everything in C is going to be shaded, but also everything in D, including that little area of people that own both a cat and a dog. That's C union D. Let's move on. C complement intersect with D. Okay, so this means you are a non-cat owner, meaning you do not have a cat. But you do have a dog. Okay, so you own a dog, but you do not own a cat. Well, this middle area cannot be shaded because these people have cats. The outside cannot be shaded because these people have neither. So what's going to be shaded? This area right here. Okay. Non-cat owners, but also dog owners. Okay, let's move on. C complement. Okay, so here I don't really need to draw a circle for D, but I'm going to anyway, just so that you can see what our picture would look like, and you won't get confused by this extra set on here. Okay, so C complement. This would be all the people that do not own a cat. Okay, so where would that? Well, everything outside of circle C. Whether they own a dog or not is irrelevant. All of this will be shaded if we're trying to shade C complement. Okay, but that circle C will be left unshaded. Let's look at another one. The complement of C intersect D. Okay, here's C. Here's D. Okay, well, where is C intersect D? This little area in the middle, right? Those are the people who own both a cat and a dog. So we want to shade everything except for that. So we're going to shade everything except for this little center area where my pencil is. Okay, let me outline this so it's very clear this is not shaded. Okay. Everything except for that middle part will be shaded. Okay, here's another one. C complement intersected with D complement. So this would be whoops. Sorry, I don't have an eraser on here, so I have to start over. There we go. Okay, so these would be non-cat owners. All the people who are non-cat owner and a non-dog owner. In other words, you will be shaded if you own neither a dog or a cat. Wow, sorry, I keep having to start over here. It's losing everything I'm doing. Okay, so we own neither a dog nor a cat. Okay, so what will that be? Well, that means I better not shade anything that's either in the cat circle or the dog circle. I've got to stick to the outside. So that's going to be everything out here. Okay. Notice this is the same as that inside part, the part that I have unshaded here. Okay, this is the cat owners union with the dog owners, meaning everybody that owns a cat or owns a dog or maybe both is unshaded. So what I have just done is shade the complement of C union D. Okay, this is actually a very important law of sets called De Morgan's law. Okay, the way I remember it, this is the complement of the union is equal to the intersection of the complements. That's part 2. Part 1, the complement of the intersection is equal to the union of the complements. So you're just basically interchanging the places of intersection and union each time. And if we draw the picture pertaining to each of these, so we'll do C and D here. This one will go with this. Okay, so the intersection, the complement of the intersection is everything except for this little part in the middle, right? Okay, that's one way to think about it. The left side on this one is probably easier to understand than the right side. It's a little more intuitive. If we come over here, what this means, I'm going to take all the non-cat owners and throw together with them all the non-dog owners, and all of those will be thrown together in a group. So if you either don't own a cat, or you don't own a dog, or perhaps you don't own either of them, you're going to be in this set. So what's that going to mean? Everybody except for the people who own both. In other words, if you're a non-owner of one or the other of them, you'll be shaded. Okay, so that means everything except for this middle part. This middle part is staying open. Everything else is shaded. Okay. Now let's look at the second equation. Okay, and this is actually the one that we just looked at. Okay, so this means if we look at the left side, the complement of the union. So if we union both of these together, it's going to be everything that's in one circle or the other or both. So inside the circles, the complement, that'll be everything that's outside of both circles. If we look at it this way, it means that we've got to be a non-cat owner, which means we've got to be outside circle C, but we also have to be a non-dog owner, which means we've got to be outside circle D. So that means we would shade all this outside part out here. Okay, and so the left and the right hand sides of this equation are basically two different ways to look at this shaded area. Similarly here, the left hand and right hand sides are two different ways to look at this shaded area. Okay, so that's your introduction to intersections, unions, and complements and Venn diagrams. We'll learn more next time, and we're going to start using sets to solve problems involving probability. See you later.